Um, Such a treat to be back. This is a sort of unaccustomed for me in-house talk about sort of a problem about Humeanism that's bothered me for a little while. But I thought in a lot of ways this was probably the best place to give it. I mean, most people know a bit about Humeanism here, at least have an interest in Humeanism, and did a perfect job of setting things up. So pardon for the, uh-oh, that doesn't look good. Okay, so I'm going to go all the way back. Well, okay, you're going to see them all at once. How do I do this? How do I go back? Beneath? Right beneath. But it doesn't scroll along that way. Okay. Sorry, guys. Yeah, okay. It's not like there's a lot to, okay. Yes. Okay. There we are. Okay. So there's a kind of tension at the heart of Humeanism. And the tension, as I see it, is a tension between the Humean account of, on the one hand, what the chances are and what the chances do. So according to the Humean, as you know, the chances are distributed patterns in the Humean mosaic, knowable fully only from a God's eye view. That is, from the perspective, at least, of one who sees the full mosaic in its entirety. What the chances are supposed to do, on the other hand, is to guide action and belief for observers who have only very incomplete knowledge of those patterns, and for whom that knowledge is limited to the past. So someone who knows, and this is just a sort of first pass at the tension, someone who knows what the chances are on a Humean account, it would seem, wouldn't need them to do what the chances do, and someone who needs them to do what the chances do wouldn't know what the chances are. So the tension is expressing itself in that sort of familiar problem about undermining that Lewis saw in connection with chance. The problem and the immense amount of energy and work that sort of went into sorting it out brought a good deal of, I think, analytical clarity into a discussion of relationship in general between a base ontology of local facts on the one hand and a vocabulary that might contain disguised information about distributed patterns, higher order correlations, things that are themselves sort of in some way information about them is spread all over through the whole pattern. Okay. So what I'm going to do is I'm going to tell the story of undermining and what we learned from it as I understand it. This should be a fairly familiar story to many of you here. And then I'm going to raise a problem that comes out of that discussion, the problem that's sort of shaken my faith in Humeanism. But I should say I'm coming here partly for help, meaning I really do think that there must be a way of seeing one's way through this, and I'd very much like sort of help with it. So Lewis started out asking what the chances could be, and he introduced the principal principle. No, I've gotten ahead here. Sorry, this is going to be problematic. There we go. And he introduced the principal principle as an implicit definition of chance that identified chances by the role they play guiding belief. So what the principal principle says in its original formulation, and the only one that will really matter here, is that one should adjust one's credence to the chances, no matter what other information they have, provided they don't have what he called inadmissible information. By that he had in mind the kind of information one gets from crystal balls. There's sort of the formula that one can write down, where credence A here is one's credence in A at some time t, and the chance at t of A is the chance of A at t. Now the restriction to inadmissible information was needed to discount cases where the principal principle clearly becomes inapplicable when one possesses, for example, information from the future of the sort one might have from a crystal ball or privileged communication from God. The problem that Lewis noticed that this poses was that this poses for a Humean account of chance has to do with the possibility of what he called undermining futures. There we go. So undermining futures are futures that are incompatible, metaphysically incompatible with the chances being what they are. So we know that such futures have to exist on a Humean account of chance to the extent that the Humean chances, the correct theory of chance, depends on how the future goes. So long as there's some degree of some dependence of what the chances are on how the future goes, the future from here, no matter how small, and so long as the theory of chance assigns some non-zero probability to any future that is nomologically compatible with the past, so things that have happened so far, that was enough to show that there would be some futures assigned a non-zero probability by the chances that were yet metaphysically incompatible with the chances being what they are. So the problem can be put in a nutshell. It's that on the one hand, chances are those things that play the role of chance in the principal principle. So whatever we assign as reference, it had better be able to play that role. So whatever chances end up being, it had better be able to play the role of guiding belief in the face of uncertainty. But on the other hand, no Humean truth maker for the chances could play that role, because any Humean truth maker introduces inadmissible information and undermines the applicability of the principal principle. It implicitly introduces information from the future in the guise of information about what the present chances are. So that's the central difficulty of the Humean account. If laws and chances are to be identified with some function of the whole pattern of facts, then beliefs about the laws and chances have to be tempered by ignorance of the facts. If presumed knowledge of the chances outruns knowledge of the facts, then we aren't going to have the kind of advanced knowledge of them that we need in a way that allows us to use them to guide credence about the future. So the reason that seems like a disaster is that chances are there to serve the epistemic function of guiding belief in the face of ignorance about the future. This is how Lewis put the problem, looking back on it in retrospect in Humean supervenience debug. Ned didn't say, but he was absolutely instrumental in getting Lewis to see both the solution to the problem and to see the problem in this way. This is the way Lewis put it. I keep wanting to hit that. Okay, let's see. There we go. This is the way Lewis put the problem in Humean supervenience debug. If I'd seen more clearly, I would have put the core of my problem in reduction like this. According to the best system analysis, information about present chances is inadmissible because it reveals future history, but this information is not as inadmissible as witness the way it figures in everyday reasoning about chance and credence. So I think the insight that Lewis took from Ned is that, one, it is true that if what the chances are depended too sensitively on the particular event E, then we couldn't use the chance of E to guide expectation about E. So for example, if which theory of chance were true depended very sensitively on the outcome of a particular toss of a coin, a given coin, then we couldn't use the chances to guide belief about that toss. But the correct theory of chances don't typically depend sensitively on the particular events that we typically use them to guide expectation about. So consider a world that consists of nothing else but a sequence of tosses of a single coin. The chances supervene on total histories. The bearing of a single toss on the chances ought to be proportional to the length of the sequence. Right? In a world the length of our world, a single toss just isn't going to shift probabilities in such a way, for this toss isn't going to shift probabilities for which theory of chance is true in any appreciable way. So we can just keep on using the chances to guide belief about the outcomes of particular tosses. And that was enough to reconcile the everyday role of chance with the Humean commitment to the existence of undermining futures. The quantitative disparity between the information contained in a theory of chance about some particular event and the information that that event carries about which theory of chance is true means that we can pretty much ignore the latter when we're using chances to guide belief. So here's an analogy. Although in principle every object exerts gravitational attraction on every other, gravitational influence of the Earth exerts on the influence that a gravitational the gravitational influence that the Earth exerts on a piece of dust so outweighs the effect that the dust exerts on the Earth that we can ignore the latter in calculating the former. So the idea is that we can get a quantitative measure of the degree of dependence that we might think of as a measure of the degree of inadmissibility about chance, and reformulate the principle to reflect that it is applicable only when the degree of inadmissible information is low. It's low in the case of coin tosses and everyday events, making chance information admissible in those contexts. And it's high in the case of undermining futures, right? And making it inadmissible. So contradiction dispelled and consistency restored. And I think what we learn from all this is that the reason that it pays for creatures like us, creatures that have information about the past, but whose information about the future is always derivative of what they know about the past, to think about the laws and the chances has to do with the balance of information. The balance of information is such that if we have a large enough body of information about the past, we can use that to stabilize beliefs about which theory of chance is true, right? And then use our theory of chance to guide credence about everyday events. So even though in principle which theory of chance is correct depends on every event, in fact our theories are largely indifferent to and cannot be undermined by beliefs about the particular events that we usually want to use them to guide belief about. If the world were too simple, or our actions and the events that we're interested in predicting are not highly localized relative to the chance and the law-making patterns in the Humean mosaic, it wouldn't work. And all of that, though, seemed to sort of make good sense and to recover confidence in the Humean. I'm getting all mixed up here. Oh, well. Okay, and to recover confidence in the Humean account of what the chances are, a very big part of what recommends that account is that it gives us a very natural epistemology. The account of what the chances are on a Humean account connects them with what we count as evidence for them, namely local matters of particular fact, and also what they guide belief about, namely local matters of particular fact. So what undermining taught us was that beliefs about what the correct theory of chance is, and hence about what the current chances are on a Humean account, are hostage in principle to the outcome of future observations, so that any application of the principle in principle has to be tempered to reflect our ignorance of what the chances are. And that means that the simple principle, which tells us what to do if we know what the chances are, needs to be supplemented with a principle that says how to let beliefs about chance guide credence where one isn't certain about what the chances are. And on this way of understanding it, undermining simply makes explicit the need for some principle about how to form credences in the absence of certainty about chances. So again, the chances supervene on the whole manifold, so they depend in part on the way the future goes. So beliefs about what the current chances are has to be tempered by ignorance about how the future will go. Okay. Now, and in principle, you could write down any number of principles about how to reason in face of uncertainty about chance. One could, for example, adopt as credences the chances assigned by the theory of chance assigned the highest credence, or divide credence evenly among the top four, or do something fancier. These won't all behave as well diachronically or satisfy other desiderata one might want. Richard is the guru of all things about this, and he will be talking, I think, a little bit about this. So you should listen to that with all of your ears. But the very simple idea that I had was that you should just create a weighted mixture of all theories of chance that are metaphysically compatible with the way that history has gone so far. And when I wrote that down, I didn't say anything about where these credences come from, that is, your credences in the theory of chance. One could think about it in a Bayesian way, or with something more objective in mind. Right? But we do want to impose the requirement that you can't assign zero probability to any theory of chance that's metaphysically compatible with history so far. And so long as you respect that requirement, you're not going to run into undermining problems. You're not going to be in the problematic position of sort of plunking for a theory of chance that's metaphysically incompatible with the future going in a certain way, and then accepting that theory recommendation to assigning it a non-zero credence. That's the problem of undermining. Okay? And the reason you're not going to run into that problem is because you're just never going to be plunking for a single theory of chance at all. Okay? At any given moment in history, there's going to be lots of different ways that the future could go, and you're going to be mixing chances drawn from all of those theories, the theories of chance corresponding to different histories. And that's true even if the world is finite, because if the world ends tomorrow, the credences I form on the eve of destruction are going to incorporate chances from lots of histories where history does continue. History doesn't end tomorrow. So I thought, well, we're golden, right? And this was a way of recognizing that if theories of chance supervene on total histories, we should be as ignorant of the which theory of chance is correct as we are of how the future goes. Okay? And it seemed to me that it was a point in favor of Humeanism, that as soon as you recognize this very natural idea, then undermining problems go away. Here, however, is the problem. And I think it's just one more twist in this sort of interplay between the epistemology and the ontology on the one hand, and the epistemic role of Humean chances on the other. So here is how I was thinking about the epistemology. I thought, we're going through the world. We're picking up information about local matters of particular fact. This is true both collectively and individually. And we're using that information to form beliefs about all kinds of things, generally what the world is like, what the laws of nature are, but also specifically where to get the best ramen in New York, right? What the way, how to get, I don't know, to JFK if you're going in during rush hour, what will happen what happened at past times and places, but also what will happen at future places and times. Now the principle entails, on the assumption again that we have no crystal balls, chances are going to screen off other sources of information from the future, because what the principle says, remember, is that if you know what the current chance of future events are, right, adopt those as your credences no matter what other information you have. Okay? We can simplify by assuming that our credences about the future go entirely by way of our beliefs about what the current chances are. Undermining taught us that knowledge of what the chances are has to be tempered by ignorance of the future. So now it looks like the whole epistemology of forming expectations about the future is going to hinge on a sensible story about how we use information about local matters of particular fact to decide which theory of chance is correct, or to form credences about which theory of chance is correct. And this generalizes to the deterministic case as well, where the chances all become 1 or 0. In that case, we're using information about local matters of particular fact to guess what the laws are, and then using the laws to generate credences or predictions for the future. Okay. Now, since the correct theory of chance supervenes on the Humean mosaic, forming credences about which theory of chance is correct is effectively just betting on what the spread of events over the whole mosaic will turn out to be. And one thinks, well, for a Humean, what could be easier? Okay? You've got an ever-increasing body of information that you're picking up from observation about what the Humean mosaic looks like over some vast expanse of the past. And all that you need to do is conditionalize on information coming in. So as information about new local matters of particular fact comes in, you cross out possibilities for the Humean mosaic, sort of mosaics incompatible with it, and then you readjust your credences. And I want to emphasize this, that for a lot of us who liked Humeanism, one of the primary arguments for it was that it gave us the connection between chances on the one hand and the local matters of particular fact that on the one hand provide evidence for the chances, and that on the other hand that the chances guide belief about. Okay. Lewis was really explicit that whatever analysis one gave of what the chances were, it ought to make sense that they should guide credence in accordance with the principal. So for example, if the chance of an event were the degree to which Angela Merkel preferred it to occur, right, that wouldn't make sense for you to use the chance of an event to guide your credence. Right? She's not that powerful. Right? So the complaint he made about non-Humean chances was that they failed this test. So he said, be my guest, posit all the primitive unhuman whatnots you like, but play fair game. In naming your whatnots, don't call any alleged feature of reality chance, unless you've already shown that you have something, knowledge of which could constrain rational credence. I don't begin to see, for instance, how knowledge that two universals stand in a certain special relation, n star, this was Armstrong's proposal for what the chance-making relation was, could constrain rational credence about the future co-instantiation of those universals. Okay. Now, I don't know if Lewis ever spoke about it, but for many of us, it was just as much because the epistemology of Humean chance was so clean and straightforward that it seemed a good theory. Patterns in the Humean mosaic were exactly the kinds of things that local matters of particular fact could give one information about. Made perfect sense, not only that chances should guide credence in the face of uncertainty, but that evidence for what the chances were would come from information about local matters of particular fact. Chance in particular, modality in general, was made on a Humean view immanent and knowable and connected in intelligible ways to evidence and to belief. And the problem now seems to me that the epistemology that I was picturing, that is the idea that you start out with information drawn from some patch of the Humean mosaic. Over time, the patch that's revealed to you by observation grows, so your knowledge of the whole gets better, and with it, your knowledge of the chances. Right? It works well when we're talking about a finite universe of known size, but I don't think it works well when you take into account the idea that the Humean mosaic has to be indefinitely extendable. So indefinite extendibility is just what it sounds like. It means that the Humean mosaic is open-ended. Right? No matter how many local matters of particular fact have been arranged and accounted for, it can be extended to include more. Okay? This should be true, I think, both along the spatial dimensions and along the temporal dimension. It doesn't mean that the Humean mosaic has to be actually infinite. It just means that there's no particular finite length as a matter of metaphysical fact that it is constrained to be. So why think the world is indefinitely extendable? Well, from a Humean perspective, to deny indefinite extendability would be to hold that the existence of some collection of events was metaphysically incompatible with the existence of yet another, and then yet another after that. Right? And that would be to deny Humeanism, because Humeanism was precisely the denial that there was any necessary connection between distinct existences. Okay? Lewis used to introduce what it meant to be distinct existences precisely by saying that the existence of one thing placed no restriction on the existence of another. Okay? There's also reason from a physics point of view to think that the universe is indefinitely extendable. In Newtonian mechanics and special relativity, space-time is infinite in every direction, and indefinite extendability is almost trivial. In general relativity, things are a little bit more complicated. In the standard inflationary model, universe is infinite, global geometry, but in fact, the global geometry is not really known. There are finite models of the field equations as well, but even in finite models, there's a version of indefinite extendability that holds. I can say more about that if you if you want. But in any case, it's not available to the Humean, even if there were reasons to think from a physical point of view that the universe wasn't indefinitely extendable. Okay. So indefinite extendability means, So the reason that indefinite extendability matters here is that the laws and the chances supervene on the Humean mosaic as a whole, not on any part of it. Okay? And any submanifold, no matter what the spread of events over that submanifold, can be embedded in indefinitely many whose total spread of events, judged by the criteria of overall fit that Lewis used to judge bestness of system in the best systems analysis, supports any chosen theory of chance that you like. So choose your favorite theory of chance, TW, the theory that gives you what the chances are at any given time on the basis of the history before that time. And give me any patch of the Humean mosaic that has already been observed. And not only can I describe a mosaic that would embed that patch and not support your theory of chance, or that would support a different theory of chance, I could write a computer program that would generate indefinitely many such mosaics until the end of time. Okay? So take any patch of a mosaic, right, and choose some arbitrary theory of chance. It doesn't matter what the spread of events is over that patch. I can give you larger manifolds in which larger mosaics in which I can embed it that would support any theory of chance that you like. Okay. In a finite universe of known size, every tile in the Humean mosaic gives us some information about the global pattern and brings us closer to knowledge of the chances. And it does that in two ways, in the sense that we increase our distance between now and the time at which we'll have knowledge of the chances, because there is a definite time at which the whole mosaic will be revealed. And in the sense that our credences will become more refined or accurate, because we'll be continuously crossing off Humean mosaics. Humean mosaics that will not be the ones that are realized. Okay. Now, once indefinite extendability is taken into account, I think neither of these senses above do we get closer to knowledge of the chances. No matter how long we go observing, an indefinite amount of the manifold or the mosaic remains. And because theory choice demands global assessments of fit, and because any submanifold is embeddable in an indefinite number of larger submanifolds that will make any theory of chance you care to write down true, conditionalizing on new observation tells you almost nothing about what the chances are. Okay? At least it tells you no more about what the chances are than it does about global properties of the manifold. Okay? So the worry is that if the Humean mosaic is indefinitely extendable, if it spreads along every dimension without limit, and is not metaphysically constrained to be of some particular finite size, okay? And chances are determined by overall fit with the whole spread of events. The worry is that and I should add here, and there's no constraints, internal to the manifold about that one local matter of particular fact places on another. The worry is that we're left without really an intelligible story from the inside of how to go from an observed body of fact to hypotheses about what the chances are. Okay. So consider a numerical analogy. You're given a two-dimensional, you're given a bunch of rows of integers, both positive and negative numbers, and you're told that they form part of an array of indefinite extent. And now I'm going to ask you about the global properties. What's your probability that the top row sums to 7,893? What's your probability that overall the diagonal contains more 5s than 4s? What's your probability that all of the numbers in the array sum to 667? If you do have probabilities, and I'm happy to say you can have whatever priors you want, the thing is that I have no idea how what you've been given counts as evidence for it. And I have no idea what you learn from seeing another number or another number after that. Okay. In the finite case, it didn't matter what your priors were. You do learn from what you see. One could say, to echo Lewis again, one could see perhaps dimly but well enough how conditionalizing on new observations would take you closer to the correct theory of chance. The worry is that once indefinite extendibility of knowledge, just like the case here, nothing that you see really takes you any closer to knowing what the full mosaic looks like. And so nothing really that you could see could bear one way or another in what the correct theory of chance is. The worry is that we no longer have a sensible story of learning from observation about which theory of chance is more likely to be correct. Okay. Now again, what made humanism attractive was that it gave us that connection. It was supposed to give us the connection between local matters of particular fact that we treat as evidence for theories of chance and the future events that they guide information about. Indefinite extendibility cuts the probabilistic or evidential link, or the worry is that it cuts the probabilistic evidential connection between local matters of particular fact and the correct theory of chance. By linking the best system specifically to the totality of facts, to the global properties of the totality of facts, humanism looks like it puts knowledge of chances beyond empirical reach just as surely as if they had been quantified relations between Armstrongian universals. So it's not only that no amount of information about local matters of particular fact. I thought you ran out on me. She's like, turn your back. So it's not only that it's not obvious how information about local matters of particular fact can be used to guide rational credence about them at all. So let me be clear. I mean, I'm beating a dead horse a little bit about what the problem is here. For the Humean, theorizing about chances is effectively theorizing about the global properties of an indefinitely extendable, intrinsically unconnected body of fact, okay, in which every single local matter of particular fact is metaphysically independent of every other. The chances are supposed to encode information about the total pattern, but in an indefinitely extendable world, they tell us almost nothing about any finite patch of it, and any finite patch of it tells us almost nothing about the global pattern. When one thinks of the Humean mosaic, I think imaginatively, certainly this was true for me, one pictures some definite manifold gradually being revealed, being incrementally and ultimately fully revealed, but without the boundaries tacitly supplied by the imagination. It doesn't matter how long we've been collecting data over what spread of space, the global spread of events in ways that matter directly for the determination of the correct theory of chances could be literally almost anything, could be in the Humean sense, that nothing in the Humean mosaic rules it out. So maybe this is fine as a matter of metaphysics, but it is not fine as a way of determining what the chances are, because as Lewis painfully pointed out, the epistemic role of chance was to guide belief in the face of uncertainty of the future. So this is why I think of this as another kind of twist in another sort of manifestation of the tension that I've called the tension at the heart of Humeanism, the tension between the account of what the chances are, distributed patterns in the Humean mosaic, and what they do, guide belief about the future in the face of ignorance. Okay. So the suggestion above has been that if science is really if what science is doing is theorizing about global patterns in an indefinitely extendable and intrinsically unconnected mosaic of fact, there's just not enough structure, that is not enough constraints to establish a connection between the local matters of particular facts and the global patterns on which the chances supervene to allow you to learn from experience about what the chances are. And it was important to Lewis, and certainly important to me, that Humean chances be empirically accessible and suited to play the epistemic role. And indefinite extendibility seems to make that problematic. Okay. So why think, though, and this is, I think, the right thought that one should have, why think that what has gone wrong here is Humeanism? Clearly scientists do, on the basis of finite information and without any initial restriction on how far the universe extends, formulate theories. Scientists do, that is to say, formulate theories that contain hypotheses about what the laws and the chances are, and they weigh those theories against one another in light of the evidence. So, and the best system analysis was really just supposed to recapitulate their practice. So whatever scientists are doing and whatever criteria they are employing, those ought to be available to the Humean, oughtn't they? Right? So let's look at what the scientists do. What sort of picture is sort of guiding the imagination when they're looking for laws? So here's just, and these were chosen more or less at random. Here's a kind of unguarded description from a couple of different physicists about what when talking specifically about a theory of everything, because that's kind of what the context in which the best systems analysis was sort of designed to make sense of. Here's Jim Hartle, physicist with about as anti-metaphysical a bent as one could want. He says, identifying, explaining regularities of nature is the goal of science. Physics, like the other sciences, is concerned with regularities exhibited by particular systems, stars, atoms, fluid flows, high-temperature superconductors. Black holes and the elementary particles are just some of the many examples. Studies of these specific systems define various subfields of physics, astrophysics, atomic physics, fluid mechanics, and so forth. But beyond the regularities exhibited by specific systems, physics has a special charge. This is to find the laws that govern the regularities that are exhibited by all physical systems without exception, without qualification, and without approximation. The equality of gravitational accelerations of different things is an example. These are usually called the fundamental laws of physics. Together they are called informally a theory of everything. Very different kind of physicist, name suppressed so that Tim doesn't go crazy. What is a theory of everything? When physicists use this term, we have deductive chain of exposition in mind, implying that there are fundamental laws describing space, time, matter, forces, dynamics, at the tiniest conceivable distance scale, using advanced mathematics. These laws prescribe how elementary particles behave, how they exchange energy, momentum, and charges, how they bind together to form the basic features of nuclear physics, of astrophysics, to form larger structures such as atoms, molecules, solids, liquids, gases. Laws have the potential to explain the basic features of nuclear physics, astrophysics, cosmology, and the material science. With statistical methods, they explain the basis of thermodynamics and more. Further logical chains of reasoning connect this knowledge to chemistry, to life sciences, and so forth. Okay, again, these are pretty generic as descriptions that one gets from physicists about how theorizing of the kind of, in the kind of fundamental theory for which the best system was originally designed. The scientist, I think, doesn't think of herself as after a summary of global patterns in an indefinitely extendable mosaic of intrinsically unconnected fact. She thinks of herself as trying to identify the deep connections behind the scenes, using regularities and surface patterns as guides to a locally available substructure that is presumed to be the same always and everywhere. So the idea that sort of guiding the practice, and that sort of co-evolved with the practice and had some success, and so emerged as a good strategy, even though there's a lot of manifest irregularity and surface complexity in the world, the idea is that if you look close enough at the fine scale structure, you will find that the irregularity and the variety are merely apparent. All systems everywhere are made of the same components, obeying the same laws, and that if we go deep enough, we will arrive at a level of description where we can isolate universal regularities, and this includes stochastic regularities. So the idea is that we don't need to go wide and look at the whole manifold to discover the laws. We can just go deep. Again, what goes for deterministic laws goes also for stochastic laws. Now, of course, the existence of this sort of deep regularity makes summarizing possible, but I don't think it can be right to think of the goal as summarizing. The goal is uncovering connections. What's really doing all of the work is a presumption that the fine scale structure is the same always and everywhere, and that if we uncover regularities in the behavior of the components at the right scale, we'll have regularities that we can export. Now, there's nothing a priori about that assumption. We can certainly imagine worlds in which it fails, but science as we know it has been built around and a practice designed to uncover those kinds of universal laws, and that can be revealed from local investigation and then combined with facts to yield predictions. So according to the Humean, facts about what the laws and the chances are tied to facts about the global pattern of events. And the worry was that indefinite extendibility makes such facts beyond empirical reckoning. I think the physics looking for fundamental laws says, I don't have to wait on information about, or form any beliefs about, or have anything in particular to do with specifically global structures or global patterns. I'm looking for deep universal regularities, immanent structures that can be locally investigated. So the physicist says, where you go wide, I go deep, or I go low. Right? So suppose we want to take this at face value as a correct description of how theorizing works. And don't worry about whether it is a correct description of how theorizing works. It's schematic and it's incomplete, and it's a gesture at a description that captures only a part of theorizing. Something different and additional needs to be said, in particular about probabilities associated with statistical mechanics, for example. But just put all of that aside for a moment and see if, at least in principle, a Humean could adopt something like this as a way around the difficulties associated with indefinite extendibility, or the difficulties that indefinite extendibility presents for an account that ties the laws to global structures. So this new way of thinking lets you guess at what happens next, effectively, without guessing about the whole, because its guesses go by way of the fine-scale structure of the universe, not by way of global patterns. So we might put it this way: the old Humean doesn't have enough structure in the domain to make it possible to learn from the data what the laws are, because the laws are these globally distributed patterns and the manifold is indefinitely extendable. The new way of thinking does, in a way, have enough structure because it relies on a certain kind of intrinsic connectedness in the manifold. It relies on the idea that there are universal laws that can be discovered by investigating local substructure. Okay. Can the Humean adopt this? Remind me later? Remind me later. Okay. I think only in bad faith. Okay. The two central tenets of traditional Humeanism are that there is no intrinsic connectedness in the manifold, and that the chance and law-making pattern is distributed over the whole. Okay. This kind of position would amount to abandoning both. I think it's not really a Humean position, at least in the way that I learned Humeanism. Of course, I don't think it lends any support to the kind of non-Humean accounts defended by people like Armstrong. And as far as I can see, it has nothing to do with whether the laws govern or describe. I think it is something like what I believe is correct, but I don't think it's a Humean position. I'd be happy to be talked out of that. Yeah. So let's go back to the array of numbers. I'm almost done. The sort of view, I think, that I've been suggesting here is much more akin to thinking of what, for example, a machine learning algorithm would do if it were looking for patterns in the array of numbers. So we train a machine learning algorithm by, on data and on some initial segment of the array, say, and use it to try to generate predictions. What a machine algorithm does is it will look for hidden patterns or intrinsic structures in the data, and then it will build a model of the source that generates predictions for new data. and correct itself depending on the new data. The model is typically an algorithm of some kind with a number of adjustable parameters. The adjustable parameters in the simplest program that generates the idea, those are the, that generates the data, those are the sort of basic degrees of freedom. The smaller the number of the degrees of freedom, the smaller the number of the dimensions along which the data can vary. I don't think this is that different from what the scientist is doing. The scientist is using regularities in the data to build a model of its source, the world, and using the model to generate predictions. As in the case of physical models, I think in a machine learning algorithm, probabilities enter in various ways, both as uncertainty about which model is correct and also as stochasticity in the model. The problem is that in order to generate predictions, the model always has to have fewer degrees of freedom than the data itself. So it can't be the case that each new piece of data is genuinely independent of what went before. I think the ability of the model to generate predictions depends on its having fewer degrees of freedom than the data. The problem is that the Humean, in insisting that there are no necessary connections between local matters of particular fact in the Humean mosaic, is effectively treating each new piece of data as if it were an independent degree of freedom. Okay, so I'm going to stop there. I should, that's all really I wanted to say. I'd like to be a Humean, so this is more of a plea for help among friends from someone who sees herself slipping away from the Humean faith. I think, so let me just sum it up quickly. It was supposed to be an argument in favor of the Humean count that it put the laws and chances within epistemic reach, made them the kinds of things that local matters of particular fact could give us information about. These are the three things that seem to me leave us without a sensible story about what the chances are from what you observe. Chances supervene on the manifold as a whole, but not on any proper part of it, and are determined by global assessment of fit. Absence of necessary connections between one local matter of particular fact and the next, and indefinite extendibility. Okay. Formally, there are things that you could do that would let you learn from what you observe. You could impose a boundary condition in the future and along the sides so that every time you fill in a tile in the mosaic, so to speak, you get closer to knowing what the whole pattern is and what the chances are. That's to deny indefinite extendibility. I don't think a Humean can do that in good conscience. You could build biases into your priors about what, about the way that one patch of the string is reflected in the pattern over the whole. I think any way of doing, I can't see any Humean rationale for doing that. So any attempt to justify it, I think, would lead one back to the non-Humean intuition that there's some intrinsic interconnectedness in the manifold. So I'm anticipating hoping for two types of reactions. One, that I'm wrong to think that indefinite extendibility has the effect that I think it does. And the other, that a Humean can adjust. Thank you.